cleared out quickly. So yeah, I'm Patrick Huck. I'm going to be talking about DOIs and Materials Project, and someone in the audience actually just gave a good segue to that in terms of how are we going to cite data, and we have the same issue in Materials Project in terms of how we're going to be able to reproduce what data people use from our project and so on. I'm from the Lawrence Berkeley National Laboratory. I'm a staff software engineer there in the Christine Pearson's group. I was in high energy physics before. So if there's anybody here that wants to talk about either material science or high energy physics, please seek me out. The Materials Project is connected to the Materials Genome Initiative, which is a White House initiative from 2011. The purpose of the initiative is to discover or make progress in the discovery and the development of advanced materials, and they should be so we can make it faster, less expensive, and more predictable, especially with topics such as human welfare or clean energy and those kind of things. The Genome Initiative, as you can see here on the right, basically brings together multiple infrastructures in terms of, well, it's a bit hard to read, but in terms of digital data, computational data, and experimental tools to make that progress in advancing materials and preparing advanced materials faster, especially when considering that the time it takes from the lab creating or finding materials in the lab and bringing them to market usually takes 20 years. So one way of going about it is to look at all the possible materials that we can create and their structures in silico in a computer, and that's what the Materials Project does. We have a few things that are special about the Materials Project. One, we have high quality materials data, so we have about 70,000 relaxed compounds with their validated energies, their phase diagrams, and so on. We have Fourier diagrams, which is the world's largest data set. We have 43,000 band structures that keeps increasing. There's a pretty intensive high performance computing tasks, and we have a few more band gaps that are higher accuracy. And very recently, we have first started with, I think, 1,000 elastic tensors a year ago. That was the world's largest data set already, and we'll keep growing it. Then we have not only our data, we also have a rapid dissemination. So we have a portal with 10 apps that enable material searching and design with different applications. We have a REST API, actually the first materials data API where the community can just download programmatically our materials data. And what we're working on recently, it's one of my other projects, is a contribution framework so that the community can contribute back to the platform and share data within the community. That's important because we just hit actually 20,000 registered users in the materials science project. It's pretty big, but of course we don't compare to Facebook or others. But this is materials science, so it's a bit different. And then the last, another pillar here is is design. That's basically why we're going through most of that effort, is to enable the community to design novel functional materials, and that goes to things like photocatalysts, thermoelectrics, cathodes, electrolytes. So there's a really broad application of things that you can do with our data if you're a material scientist and interested in those things. The website is really a science gateway. It's at materialsproject.org. All the data that we have and produce and all our codes that we use to produce that data are open source and state of the art. So we're also on GitHub, Materials Project. The codes that we developed, for instance, for our workflows, that means like connecting different calculations, materials calculations together is Fireworks, and then the analysis code to do materials analysis is PyMagen. And we also have Custodian, which does all the failure recovery when the jobs are running on the batch farm and others. So all those codes you can find on our GitHub page, and we're following all the best procedures to keep this open source, which is something very new in general in the material science world. If we look at the Materials Genome Initiative and the informatics that's involved, you can think of it sort of as like a molecule. And there's a few blobs here. One are the analysis codes and the data dissemination. I've talked about it. It's PyMagen and REST API that that come into play here. Also, things recently that we started is we called it website, which is basically a tool to write application, or for a user to write web applications that would either plug in with the materials project directly or run on its own sources pretty easily, including REST API and others. But at the heart of it, there's Fileworks, which is our workflow software and takes care of the data pipeline and the data curation. And one thing we've recently opened up is the community contribution. As I've said, this is something we're working on because we have an existing community of 20,000 people, and the request usually comes back that they want help in either exposing their data sets to the public or want to contribute back to the materials project because they have used materials project so extensively. And the framework that we're developing, as I've said, is MP-contribs for it, but there's also a service called MP-complete, which we use for users to suggest new structures to our platform that we then calculate with our standard calculations and add to our core database. Let me just quickly show those two. So MP-complete, as I said, is a new service for the user community to suggest new structures and get them calculated by the materials project. It assigns an identifier, it runs the calculation, and then adds the material to our core database. So it's really part of the well-defined data set that we have, and that runs our web page. What usually happens on our front end, we have a interface that lets you load up structures in their standard format, and you submit it, and it goes through that whole step of successive materials calculations, also simulations that run on high-performance resources that can either be at our own if we're using our own resources, or in that case it's at MPCite in San Diego. So the part that does the completion of the data set, the MP-complete part, is outsourced to another resource, but we do our own core calculations and increase the data set locally at LBL, and after a time, when that workflow finishes successfully, that material, in this case KNB03, ends up with a new MP ID. That's what we call our identifiers on the project with the right attributes and so on. A second thing I want to briefly introduce is MP-contribs. The purpose is, again, to contribute data and disseminate it through the materials project. The initial motivation for people to do that is that they need help with sharing their data sets, and they've already worked with materials project, so that's a go-to platform for them. And what they expect in the end is that, you can see that on the right, that's an example for one of our materials detail pages, and where they can spin the molecule and they can look up basic data and how we calculate it, band gaps and other electronic structure properties. Their goal is twofold. One simple goal would be if they contribute alternative calculations, they want them to show up on our page, or if they contribute complementary data, they usually have the goal to develop a customized app or a customized representation of that data so that other users in our community can explore the data set. And we're working with people at ALS with XAS spectra, and people at UW with diffusion coefficients, so experimental data as well as theoretical data as use cases to get them into the materials project and develop that framework. The goal is in the end to become a hub for theoretical and experimental data in a way that it's effective to disseminate and expose that data to our user community. There's two demos that you can click on if you're interested on how that looks in detail. One thing my talk is going to be about today is MPCite, which is a package that we just started writing recently and is for the purpose of citing our materials data. Right? I've shown what data we provide, and it's quite a big data set with 70,000 structures. The problem that we're having is that we usually give this link, materials project citing, and we ask users that write papers to cite our data set and at least give the generic citation or as a reference. And there are other citations and other papers that, depending on what tools they use in our platform, which they would have to cite. But what happens if you look at two examples here is here one user wrote, our database contains DFT bands. DFT is density functional theory, band structures for 3,000 oxides. We have taken their first principle relaxed crystalline structures as available in materials project. So we have relaxed the structure, we've calculated all those structures and put them online. And they cite us, but the way they cite us, you see, is as our link, which is good, and then the generic first paper that was written about materials project. Same further down in the same paper, like we considered all compounds containing a certain set of atoms, and we got them from materials project through our REST interface and so on. So for many papers that are out there in their analysis, our data set and the things that we calculate is a basis. But the question really is now, when I read this paper, for somebody who doesn't or wants to reproduce that analysis or even check which ones, or a day later want to check which one did they actually use, and did they give a link to the data? Like they did as materialsproject.org, but somebody would have to go through the list and look at especially which ones those were. So the question here is, and the obvious solution is to assign DOIs, digital object identifiers, to our materials data set. Our materials data set is well suited for this kind of work because every material, which is a set of similar inorganic structures, is a good match for DOIs. Because usually that definition of a material, which is not well defined across the materials community, but we have a materials definition that is well known for users of the materials project, that definition is unique and stable, right? So if there's new materials added, they get checked whether they have duplicates within our database already, and all of those 70,000 structures that we have are well calculated and tested. So assigning DOIs to each one of them is a good way to go to get a persistent identifier for our DOIs and a link to our data sets. There's many reasons to use digital object identifiers. First of all, they have pre-existing global recognition. Everyone knows DOIs, and they're accepting them in publications. There's standardization through organizations like IDF and ISO. IDF is International DOI Foundation. So there are real efforts behind in making DOIs persistent. It enables a long-term discovery of research objects. They never die. DOI links always are available. They're stable. There's better attribution for researcher and producers in giving that DOI around. And one important part is, when you come from the funding perspective, is that it's easier for sponsors to track impact and make a budget based on which data was produced and the DOIs that were available. So for DOE funded projects, there is a way of getting DOIs without going through a big spending of money. There's something called DataCite, which is a global nonprofit that is comprised of local institutions, and they want to improve the scholarly infrastructure of data. They launched only in 2009, and if somebody wants to hand out DOIs to clients, to data clients, they have to be so-called allocating agents. So there's actually a whole process behind how you become a member. And there's 3 US members there, and it's the California Digital Library, the Purdue University, and then something what's called OSTI, which is the Office of Scientific and Technological Information. And that's where it gets interesting, because OSTI serves the DOE with what's called a data ID service. And that data ID service is free for DOE-sponsored projects. The materials project is part of the Lawrence Berkeley Lab, which is a DOE facility, and we're sponsored by the DOE. So this is a way for us, if we work with OSTI, to get DOIs for all our materials. They started assigning the first DOI in 2011, so that's pretty recent. What they provide, as I said, is the DOI ID service. There's a link where you can check out more, but basically it's a whole infrastructure that for ingesting information, submitting the data to assign DOIs, register DOIs, and the whole infrastructure to make it easy for DOE users to request DOIs. A basic workflow of that ID service, and just to show that DOIs is actually something serious and not that easy to get. So it takes some effort to go through and make sure that the data that is assigned to a DOI is valid and therefore for the foreseeable future. So in the planning stage, what happens is that the submitter's responsibilities are discussed with OSTI. So it's something we went through already in the preparation of assigning DOIs to our materials. And there's a few things a submitter has to do. He has to provide the metadata. He has to have the authority to make the data public. As soon as a DOI is issued, there must be a landing page with it. So there must be at least a public landing page. Then there's maybe the most important point 3 here is that the data. So he should be the guy ensuring that the data is stored and maintained such that access is always there and indefinitely there. That's good for a materials project because that's our goal. Everything that we've out there, our links to materials with our MP IDs, they're already persistent, right? So we fulfill that inherently. If somebody comes with this private data set, he wants to put it online, he first has to solve that problem. And then he also needs to maintain and update the URLs that come along with a DOI. Which in most cases is, like I said in that 4-point, is the landing page. And the landing page for a DOI is the one important thing. It needs to be publicly accessible, especially if data sets are restricted or temporarily restricted. They are mandatory because the DOI needs to point to something. And when there's special software that's needed, but most importantly, since data site and DOIs never get retired, so once there is a official DOI issued, that DOI always stays valid, and the landing page always has to stay valid too. So this is, any effort in assigning DOIs is a serious effort in making your data available for the foreseeable future. And there's, as I said, there's foundations behind it that make sure that those things happen. Another thing, and that's an important question for people that are new to DOIs and want to assign DOIs, is what level of granularity do I want, right? If I have a data set, do I just give that whole data set one DOI, or do I split it up? For us, it's been pretty straightforward because we have the definition of a material, and our idea was that every material gets a DOI. But that means 70,000 DOIs, which is pretty much unprecedented. In the developing phase then, and that's where the user comes in, the data clients, that's us, materials project. If we're doing this with high volume and high frequency, so in our case, 70,000 materials, there needs to be an internal process that pulls the metadata from our sources, so that's our Mongo database in the background running our materials project, then formats it in a way that OSTI can read it, and that's a correct XML format, and then we'll send it to what's called E-Link, which is their web service to start requesting DOIs. So you see, in our case, it's our database on the left, materials project, and in the middle of it is MPCite. That's basically the service and the library that I wrote to make this whole thing possible. But you can already see that something like that is needed for other research field tools that have a well-defined minimum unit, and that they want to assign a DOI for, but they want to do it in a high throughput mode, right? So with high throughput, I mean that the E-Link service has not really been tested so far to just send 70,000 requests at once and do a 70,000 DOIs overnight. So this is something that runs over months, right? So it's a cron job or a task manager that continuously runs in the background and starts picking up materials from our database, prepares the XML, sends it, waits a day, and then makes sure it's valid and puts it out there for users to use. And we're going to go through that process in a bit. And then after we would have caught up with all our materials, we're still producing new materials. So MPCite would still be running, requesting DOIs, and continuing that assignment process. In the testing phase, that's before we go into production, with OSTI needs to check that we don't have connection problem, XML format, landing page validation. So all that stuff happens in the testing phase. Also, the DOIs that are in the testing phase and in their test environment, they don't resolve. So if you click on them, they won't lead anywhere, and they'll expire at some point. But that's during the testing and developing phase. Once we're in production, which is a pretty important step, you can see that we're now closing the loop. MPCite would get materials from our database, a set of materials, batch of materials that doesn't have DOIs yet. It would send them to E-Link in the right format. And then overnight, E-Link would validate the landing page, so it must be reachable. There shouldn't be another entry with the same URL in all of the DOIs. So the mapping between DOIs and landing page is unique. You can't ask for a new DOI for the same landing page, which makes sense. And it converts it to what DataCite needs. DataCite is the point where all the DOIs actually live, and they give them out, and they also give unique prefixes to OSTI for a certain data client. So us, the materials project, has a defined prefix, and then we get specific identifiers after that prefix. And also E-Link sends out instant notification based on their API response and also emails and stuff. So there's a whole framework in there that makes sure that once a DOI is requested, those things stay in place. And once it comes back from DataCite and DataCite has validated, E-Link updates its database, but it also releases that entry to what they call the data explorer. So they don't not only have the infrastructure to request DOIs, they also have the infrastructure or an interface to look at data and explore data. And that data explorer then shows a link and a description, all the metadata that was submitted, and that DOI link then resolves back to our landing page. So this is where that loop closes. A few words for the interface before I show a brief demo. As I said, the steps that are happening is first the submission steps. So you can see here that I just said like submit 2 materials. In our case, that means get 2 materials that don't have a DOI. I generate the XML records for it. I start the submission, and I get the response back that everything is OK. I can also submit specific IDs, right? So in our case, MP123035 and the other one also comes back as a success. 2 things I want to note is this submission step also automatically handles updates. As I said, if you submit to OSTI, you can't submit with the same DOI with the same landing page twice, but you already have an identifier, and you can resubmit if you need to update metadata, if there's a new landing page, if there's a new research organization. This is all these official things that somebody from the DOE would know, and would need to know to figure out which projects were funded with a certain budget. And second thing is it also handles duplicates. So if things happen to not be in my canonical collection, it gets them back from E-Link and keeps everything in sync. The second step then is build this stuff. The reason those 2 are separated is it takes overnight at least to get the DOI. So as soon as you request the DOI, you're not ready yet to show it and to resolve. It doesn't resolve yet. It needs to be validated, go to DataCite, and so on. And that's where the build process comes in. If you run MPCite build on a certain MP ID, it'll validate it, so it'll ask E-Link and DataCite whether the process is completed. And it'll also go to the data explorer and ask for a BibTeX request. You can see here that it failed with the 404. This is in the development environment. The reason I'm showing it is that it gracefully handles those errors too, right? That stuff always happens, and you have to know that MPCite is going to run for months without anyone looking at it. So that stuff has to be graceful. If an endpoint is down for a while and it gets checked next day, it'll do it without me intervening. And it won't build anything or put anything on the homepage that is not ready yet to be shown. Because what happens after the build process is that there's a little button. I'm going to show that in a demo where you can basically look at the DOI, download the DOI, and only not all of our structures have DOIs yet. So that's what that process makes sure. And one thing I highlight down here is that with MPCite and with those processes, that becomes a 2-way street. So not only MPCite sends stuff to E-Link, it also gets information from E-Link to keep our information on our site up to date, and also ask for BibTeX strings so that people have an easy way to cite. So here is an example page. I'm not going to click on it, but this is what it would look like. 10.17.188 is our data clients, our materials project DOI, and then this is a unique ID for that details page. There's also with MPCite, there's a set of admin commands that reset, sync, monitor, give you info on on the databases. So in that regard, MPCite, even though it's materials project specific, is easy to extend to other projects that need to work with OSTI and request DOIs from OSTI. We've had a 2-month trial run in 2015 that showed that this is feasible, and you can see that back then we ran it daily and increased the number of DOIs we request, and there's been a lot of things in the background since this is the first time it's been tried on that scale in talking to their APIs and features that OSTI didn't have, and timeouts on their API and a whole litany of things. But it worked well for 2 months, and we made it up to a 20% coverage. You can see that sometimes I think this is a weekend phase, so DataCite doesn't validate over the weekend or so you have to actually wait until, if you request on Friday, you need to wait until Monday to get it. Something that we noticed. But you can see on the scale that we're up here to about 12,000 materials, 12,000 DOIs. Out of our, back then, 60,000. Now we're at 70,000 materials. So this thing needs to be running while our materials database is growing. And that effort alone made materials project basically OSTI's star data client. And we need to know OSTI's been around like for 70 years now, and they're in a phase of trying to figure out what services are most important for their researchers. Oh, all right. I'm almost done. I have one more demo. That's all I want to show. So let me go to the, before I finish up to the data here, let me see. Can I finish that? Okay. I would probably have to mirror it now. There we go. That works. Okay. So this is OSTI's Data Explorer, and you can also see this is recent content. There's materials data on lithium sulfate here, and there's another one here. Let's look at that one. This is what a generic entry at OSTI would look like for a specific material. There's our own identifier. There's the identifier from OSTI, and information that's important for funding seed, like the funding agency, what subject it is, what the research organization, what the sponsoring is, and so on. So this is really, once the data is produced and public, this is important for funding purposes. So one thing I want to try now is this is the ID that I want to look at, and as I said, this is a recently submitted DOI, so it's not yet built in our infrastructure. This is E-Link now, and I can go and look at that ID. You see it's completed, right? And also in the Data Explorer, I can look up that entry and get a JSON entry back. So it went through that whole background of production. And on our end, and that's the last thing I'm gonna try, is fingers crossed it works. I'm not sure. I'll have to. Oops. Because after oops, that was bad. Sorry, guys. After I go through through that submission process, I need to build it, and once the DOI is built, it'll show up on our web page. So one thing I'm gonna try now, and I hope that it works. Let's see. So this was. I'm trying to build this MP ID here and get it on our web page. If I go on, let's see. Yeah, it's in the discussion. I'm done. I just want to show that last thing here. Sorry.
Any questions?
Yeah, if you can. So this DOI really links to our landing page that I've shown before. Hello. Oh, there it is. And you see that there's no DOI yet. And the last thing I want to show is just this DOI. It's validating, it's saving the bib cache, and it built it into our materials collection. Once it's in the materials collection, I should be able to reload that.
Okay, so I think we have time for one question.
Yeah.
So one of the cool things about the DataCite metadata is you can supply information about other formats that resolve URLs. Do you do that in when you're minting the DOIs?
No, for us it's a one mapping. We have all the other metadata in there too, right? So like the research organization and stuff. But it's basically, I think it's mostly the basics that are required, not the full set of things. This is a specialized mix of data, and that's all. So we don't have special programs that you have to open it, and so that doesn't apply.